Good morning, my name is Richard Evans, Regional Sales Manager for Foster & Freeman, and today I'd like to welcome you to our webinar about remote document examination. As usual, to simplify proceedings, all guests are muted during the presentation. However, please feel free to ask any questions via the chat box at the end of the webinar when we do our question and answer session, and we'll try to answer as many questions as possible. So, remote document examination, and we're going to be looking at how we can use VSCs to examine question documents across a secure network. So this is a relatively new development, and it's mainly because of advances in technology that we're able to do this today. So, for example, many years ago, if you had an expert in one location and there was a document at a different location, if the expert wanted to examine the document, then either the expert would have to travel to the location of the document, or the document would have to be sent to the location of the expert, and that takes both time and money, and especially the delay. It would not be possible to do a sort of real-time examination. However, what we're going to show you today using the new technologies is that it is possible to do remote document examination in virtually real time to enable the expert and the documents to come together across a customer network. Now, since 1979, Foster & Freeman Limited have been making VSC workstations, and they've become the forensic question document examiner's tool of choice. And each new generation builds on past experience, adding new technology to create an improved VSC. The VSC Development Cycle is driven by technological advances and by new challenges presented by counterfeiters and criminal organisations. We also take customer feedback from our personal customers. We also look at advances in document security. So quite often there will be new technical security features put into documents, and we have to try and pick and choose which ones of those are going to become common in the marketplace so that we can put the relevant decoding functions into the VSC technology. We also try to keep abreast of what's happening with the counterfeits themselves, looking what the counterfeiters are doing so that we can design the VSC accordingly. And then of course we also have our own inbuilt design and test team at Foster & Freeman, who also come up with our own advances throughout the years. And so we take today's VSC, enhance it, remodel it to give you tomorrow's VSC that's a tool suitable for the document examination of tomorrow. Today, one of the biggest challenges in question document examination relate to migration and the number of people crossing borders. Countries all over the world are securing borders against cross-border terrorism, illegal migration, human smuggling and trafficking, and other criminal activity. And many countries are working to secure themselves against this threat by both working internally amongst themselves and often also internationally as well with partners. Criminal gangs will use a variety of different fake documents to facilitate a variety of crimes. Sometimes they may even use genuine documents themselves that have been stolen from reputable sources and manipulate the genuine documents as well, which can be particularly hard to diagnose. So in order to guard against this large-scale fraud, we require an increased physical border security, including more control points and the outward expansion of border controls as well. We need greater question document capability to authenticate travel documents and ID documents quickly and rapidly. And we also need better sharing of information to communicate amongst control points and identify common threats, so that when a new threat is identified, we can quickly send that information to other control points so they are aware of the type of counterfeit documents or threats that may be coming to them very, very soon. Now, the problem with this is the increased physical border security, the question document capability, and the better sharing of information. It doesn't come cheap. It costs time, it costs money, and it costs a lot of training in people to actually achieve this. So Foster and Freeman have also been thinking about what we can do to help and facilitate the advances in question document examination. And what we came up with was not really a new product in itself, but a new concept that we call remote document examination. And to summarise it here very simply, it is the sharing of fully digitised documents containing examination quality images and associated document data across the customer's secure network. So just basically the sharing of very, very high quality images, maybe taken with different wavelengths of light such as UV, infrared, shared across the customer's own network so that they can examine the documents remotely. Now, remote document examination has been mainly made possible through the development of our ultra high quality capture instruments such as the latest VSC PDI for the rapid capture of high quality images. And secondly, it's used with VSC Link, a new software interface that enables networked users to share digitized documents from a VSC even to a remote station that does not have a VSC. So VSC Link, as you'll see, can be just installed on a PC and used totally independently of a VSC itself. The VSC PDI offers one-click capture. So macros can be programmed into the PDI, and then the PDI will automatically capture images of ultra high quality using different wavelengths of light, including UV, visible and infrared. It will also capture different embedded data types such as IPI or letter screen, and of course it will enable you to examine the chip information and the MRZ information as well. And then these images can either be examined locally or they can be sent to other VSC workstations or a VSC Link workstation.
In this example, we will examine this particular passport by placing it within the PDI, closing the lid, and then selecting macros from the tools. Here we already have a particular macro set up for this particular passport, but we can create as many macros as possible for different documents or different countries. Click Run Macro to begin. Here we are checking the document position and the focus. If this is OK, click OK to begin the macro itself. So these are the results of our macro, and here we can click Save, so ensure all of the images and data is selected, and then here we can select a particular folder on the network which can then be accessed using the VSC Link software. So now in a different location using the VSC Link software without any VSC connected, we can import the images captured from the PDI and then begin our examination remotely. So at the top we have the same images that were exported from the PDI imported into the VSC Link software, and we can double click on any of these to load them, and then using the mouse wheel to zoom in and magnify and look at areas of interest. Here, common areas of interest would be the stitching, corners of the laminate to make sure that it hasn't been tampered with, and also the print type itself. And various different parts of the document are printed using different printing technologies. We can also do comparisons loading any images that we have in the gallery. In this example, we could load the visible lighting and also the infrared side by side. And using the link zoom, we can again compare different areas of the document under the two different lighting techniques simultaneously. The VSC Link software also contains the majority of the software features included within the PDI and the various other VSC instruments, such as MRZ, barcodes, IPI, latent image. In this example, we can also run the MRZ test again. So after loading the image, simply click MRZ, and the software will run the check on the MRZ in exactly the same fashion that we did on the PDI. Here we can see that the MRZ check digits are all correct, and we just have one warning that in this example the passport is expired. We can also use the results from the MRZ to search against the database if installed. So in this case, we can click on the Documents Database icon, and we can see we have a match in our reference database. So the left we have our captured image from the PDI, and on the right is our reference image. We can see by zooming in on the two images that the difference in the quality of the images, partly because the reference database images are generally much lower resolution and were generally captured before a time when the PDI was around, and now the PDI is being used to generate databases around the world. So we can really see the difference in the resolution. If this is not the correct entry in the database, we can also scroll through and look at previous generations or to find the correct iteration of that document. In this example, we're comparing just the white visible light, but there are other images in the database of the different pages, so we can have a look at those if they were originally captured on the PDI. And we can also have a look at the different lighting. So in this case, we have a UV image, and I can bring in our UV image captured on the PDI, and again, we can compare. We should also be able to do the same again as well for the infrared. And again, we can compare side by side. The database also includes text data about the document. It includes the validity, when it was introduced, size, and whether it's an e-passport or not, as well as other information as well. If the document you are examining is not in the database currently, you can add to the database. So by clicking on this plus icon, you can use the images that have been sent to you, and you can add the relevant information here after selecting the country of origin and the document type.
The remote examination network can be as large or as small as the user requires, and there are many different formats that the network can take. The files or the image files are shared via the customer's network or via an inter-organisational network or even via the World Wide Web itself. Now, the network can take many forms, such as one-to-one. So you could, for example, just have a single PDI unit feeding images to the VSC Link, where they could be examined remotely, and then the VSC Link operator can send messages back to the VSCPDI, warning them or telling them about information, or even just reporting back whether they feel the images show that the document is genuine or counterfeit. The network can also be one-to-many, so the VSC Link operator may have many different PDI machines, for example, linked to him, feeding him back information. He can be there examining the documents that are remotely sent to him and communicating back to the network points to say whether he feels, in his opinion, those documents are genuine or not. And of course, all these images that are coming across the network can be stored in a central location on the customer's network and could be accessed at a later point as well. Now, although we keep talking about the VSCPDI, the VSC Link software is not limited to working with the PDI. We particularly talk about the PDI because it offers the most maximum image quality that you can get out of any of the VSC machines. But that doesn't mean to say that you can't use any of the other current VSC machines with VSC Link. The VSC 8000, VSC 8000HS, the VSC 800, the VSC 80 and the VSC QC1 are all completely compatible with the VSC Link software, and you can have many different types of VSC machines on the same network, sending the information back to the VSC Link headquarters. Finally, you can have a network situation such as this, which is many to many. And using this type of network arrangement, users can not only send information back to the VSC Link, but they can also send information back to any other VSC workstation itself. So the information can go from anywhere to anywhere and flow in both directions. Now, obviously, networks are not a particularly new thing. They've been around for quite a while, and sending images across a network are not particularly new either. But what's really changed here is that the quality of the images that we're able to now send have got to such a high quality that that's what makes the remote examination possible. So let's have a look at how this works in practice. So let's imagine now we're just starting to use the PDI and the operator has a macro facility. So he would typically maybe take images in white light, infrared light and UV light, and maybe many others as well. And those high quality images would be captured and sent. The local user using the PDI could also obtain the MRZ information. He could obtain decoded information from IPI or Letter Screen Plus if that is present in the document, and of course he can also receive the information from the chip itself. So once all that information is extracted, the information can be sent over the customer's network and received at the VSC Link terminal. Now the PDI, as we've said, offers incredible image quality. It offers the ability to do multispectral illumination using many different wavelengths of light and different types of light, and it also enables us to do automated capture. And as we said, the automated capture macros can be set up by experts, or depending on the security levels, they could also be set up by local users as well. And you may have many different macros stored on one PDI machine for examining different passport documents from different countries. Now, while many other VSC instruments over the last few years have been able to do this, the VSCPDI has been specifically designed for this purpose. So yes, the VSC 8000 produces, or VSC 8000HS produces incredible quality images, but in fact the PDI takes it to another level. The image quality from the PDI is both greater in optical quality, and it's also greater in the number of pixels that we capture too. So here, for an example, we have an image captured from a sample document. Now, unfortunately, because of the quality of the streaming from the webinar, you will not be able to see the quality of these images over this video link. However, if you did want to see some example images, we'd be very happy to send you these after the webinar has finished. Just send us a message at sales@fosterandfreeman.com and we'd be happy to send you some example images, even of a document of your choice. So let's have a look at an example of an image from the PDI itself. Now, the standard images are ultra high quality 45 megapixel images. However, we can do some manipulation of the images to create very sharp images up to 191 megapixel as well. And when you have this type of resolution, you're able to zoom in to the image to look at the printing techniques or to look at alterizations that you cannot see with the human eye. And this is all possible remotely because of the size and quality of the images. Now the VSC PDI also uses another type of technology to optimize the image quality, and this is called flat field correction. And this ensures uniformity of illumination by eliminating shading distortion often found when taking photographs of documents. And you can see on screen here the difference that can be seen with and without the flat field correction. With the flat field correction we get a much more even, realistic image compared to what you may see than without using it. And there is a common thing in cameras at the moment to be able to boost the colours a bit to unnatural levels, and this sort of technology really helps with that. We can also use the flat field correction when looking in the infrared, and when we see it here you can see that the image that has the flat field correction applied, we're able to see a lot more detail than without it. The quality in particular of the intaglio can be seen much more clearly now than it could be before. Now going back to a visible image, here again are two images taken with and without flat field correction. And in this case here the examiner may be looking at the curved corners of the document to see how well they've been cut or if the document has been lifted. And again, using the flat field correction we're able to get a much sharper, crisper, realistic image that enables us to see much more detail in that area of the document. We also use the PDI to capture images from holograms and kinograms, and we also have the ability to illuminate the hologram or kinogram from different angles of light and then put these all together to create a composite hologram. So this is how the hologram would look when all its individual components are put together. And some of the users that we've showed this to have never seen their holograms in so much detail and quality, and that also applies even to the manufacturers of the holograms as well. The quality we're able to get from the PDI is without rival. Now another function that the PDI is also able to offer is 3D imaging. Now this has recently been added to our VSC 8000 and VSC 8000 HS machines, but we're also able to do this on the PDI. And the 3D imaging can be very useful for looking at intersecting lines, indentations, defects, and also 3D printed features that may be present on the document. Here we see the intersecting lines, first of all shown in a colour image, and then secondly using the 3D imaging in the infrared. And the document examiner can look at these high quality images and make a determination as to possibly the sequence of lines. But it's not just all about written inks. Some other security features that we typically find on passports can also benefit from 3D examination. So here we have a latent image feature, for example, on a UK passport, and using our normal latent image decoder in the VSC, we're able to get a reasonable image of the latent image. However, if we actually use the 3D imaging software, we are able to get a much more striking image that shows a lot more clarity. Another recent addition to the VSC range is facial recognition, and this is an optional module that can be installed on many of the VSC machines, including the VSC PDI. And using the facial recognition software and camera system, we're able to match faces between the e-chip photo, the passport data page or identification card data page, and also a live webcam capture. So up to 5 different images can be captured and compared within the software. And again, some of these captured images that are sent to the VSC Link operator could also be compared at the VSC Link station without the document actually being present there. Now the facial recognition is a really useful tool, and using the VSC as well at the same time, we're able also to remove the holograms or kinograms that are often put across the colour image of the person in the ID document. So here you see an example where the lady in the picture actually has several security features hiding her face that cannot be clearly seen. But then by using the VSC, we were able to remove the security features so that we can just get an image of the person themselves, which can then be used with the facial recognition software. Another new feature we've added to the PDI is actually automated colour correction. Now, more and more our customers have asked us for very high quality images with a high colour accuracy. We want to see the colours as they are printed, not as the monitor boosts them or the camera boosts them with artificial correction. So on the PDI now we have a new system using X-Rite colour checker to enable the system to basically be calibrated so that what you see is what you get. The colours are as true to life as possible. So that's why we use the PDI for remote document examination. It can be complicated or easy to use depending how you want to use it. It offers incredible unrivaled image quality, and it enables images that can be sent over the customer's network to enable remote forensic level examination. So looking a bit more at the VSC Link software itself, the VSC Link can be put onto any PC running Windows-based software. It doesn't have to have a VSC connected to it, but it could have as well. And the combinations of the VSC workstations could be 8000s, PDIs, 800s, 80, ATIs or VSC QC1s. And so you could have a very wide and diverse document examination network. And the examination images that we take from these machines and the relevant data that's captured at the same time can be captured at remote locations, maybe within a country, maybe within an area. It could even be across several countries if your customer network wanted to support that. And then the image is sent back to the VSC Link control. The VSC Link control could also send out alerts if they feel that there's a document being found commonly, to notify the border crossing points that they should be looking out for a particular type of forgery. So remote document examination, as a summary, VSC Link is compatible with any current VSC instrument. So unfortunately, if you're using a VSC 40 or a VSC 6000, it's not compatible, and we do apologise. But any of the current range of document examination equipment is compatible with VSC Link. And it's the ideal solution for document examination networks of any size. As you grow your examination network, the VSC system and VSC Link can grow with you. And the VSC system, VSC Link, is an ongoing development. So again, as I mentioned earlier, we're taking customer feedback, we're taking our own input into the system, we're looking at technological advances that are happening within the document examination world and putting this into the VSC Link technology, which is improving all the time. So without further ado, we'll start to have our question and answer sessions. We hope this webinar has answered questions about what remote document examination is and how it can be used in practice. So it's over now to myself and our application specialist, Mr. Dan Freeman, who will be happy to answer any questions that you may have.